Hello, everyone. Uh, I hope you guys have a wonderful day so far. So please, guys, I just want to make sure that you guys know that this is completely new to me, and I know that is completely new to you guys. So please be patient with me. And I do my best that I can take care of you guys. Please, guys, don't get panicked. This is for everyone. Just make sure, take care of each other, love each other, and God bless all of you guys. Okay, so let me start where we stopped last time. So the last time, if you guys remember that the problem example 3 on page 332 using the binomial probability distribution function. So the question is, according to the CTIA, 41% of all US households are wireless only households. In a random sample of 20 households, what is the probability that exactly 5 are wireless only, fewer than 3 are wireless only, at least 3 are wireless only, and the number of households that are wireless only is between 5 and 7 inclusive. Okay, first, let me just remind you guys. It says, oh, Mr. G, how do I know this is a probability distribution function? So first of all, each 20 households, that the sample of 20 households, each household have nothing to do with others. So that means the samples are independent. So we're good to go for that. And then we have a success and failure. Success, that means they are wireless only, and failure, not wireless only. And then the 41%, the probability of success is the same for all 20 households. So we know that this is definitely is a probability distribution. So now I'm going to, I did part A in the class and I did part B. So let me review part B and then we go to the part C. At least 3 are wireless only. So here, part B, it says fewer than, again, fewer than 3. So when I said fewer than 3, that means 3 is not included. So the X is less than 3. So it could be, so that means the value for X could be 0 or 1 or 2. And again, guys, remember that I told you guys or means addition. So that means it's going to be, so let me use, yes. So you see that is going to be P of 0. So P of 0 or plus P of 1 or plus P of 2. So I'm going to calculate P of 0, P of 1, P of 2 separately and then add them up. So again, guys, since this is a probability distribution, so the P of 0 is going to be number of ways that I can choose, number of ways that I can choose 0 success out of 20 out of 20. So that number of ways, again, number of ways that we can choose 0 success out of 20 distinct objects. So times probability of success, that is 0.41 based on the problem, to the power of success, the number of success, that is 0, times probability of failure. Again, guys, because probability is between 0 and 1, obviously if the success is 0.41, the failure is going to be 1 minus 0.41, and then to the power of number of failure, that is going to be 20 minus 0, that is 20. And then we do the same process for P of 1 and P of 2, as you see, guys, and then we calculate each one. And then when we calculated, and then we add them up, all each probability, P of 0, P of 1, and P of 2, when we add them up, is going to be the final answer. The fewer than 3 is 0.0028. So interpretation, the probability that in a random sample of 20 households, fewer than 3 will be a wireless only household is 0.0028. In 1,000 trials, when I said 1,000 trials, that means I should let's see, it means, so if I multiply this, let's see, is, so, okay, so I think I cannot write it here. So again, guys, 0.0028 times, if I multiply by 1,000, so again, how many zeros we have in 1,000? 3. So if I move this decimal point 3 places to the right, so it's going to be 2.8. And since 8 is greater than 5, so we rounded to the 3. So we would expect about 3 trials to result in the fewer than 3 wireless only households. So so let's go to the next page. So, okay, guys, so this is, let me go back one more time. So this is a fewer than 3. So now the next question is at least 3 are wireless only. Okay, guys, when I said at least 3 are wireless only, that means this could be 3 and more than 3. So it could be 3, it could be 4 or 5 or 6, all the way to 20. Again, guys, the question, do you want to take each probability and add them up? No, that's, again, we don't have a time, and the time is precious. So I want you to do a shortcut. So again, guys, since we already know the probability fewer than 3 are wireless only, so it's 0.0028. I'm going to, again, page 333. So we are looking for part C. The value of a random variable x that are at least 3 are x equal 3, 4, 5, all the way to 20. So rather than compute p of x greater than or equal 3 directly, I'm going to use the 1 minus, so I'm going to complement rule. I'm going to use the complement rule, and then says, okay, 1 minus the probability of fewer than 3, that is 0.0028, and 1 minus that give me the rest, that is 3 and above 3, that is 0.9972. So for the p of x greater than or equal to 3, the probability is going to be 0.9972. So, and again, in 1,000 trials, and again, if I multiply this by 1,000, is going to be, because the 2, again, I move it, I multiply by 1,000. So let me see if it works here. Yeah, times, so if I multiply it by 1,000, so 30, so I move it 3 places to the right, so it's going to be 900. We would expect about 997 trials to result in at least 3 being wireless only. So Now let's go to the last question. So again, the last question is, let me go back to the number of households that are wireless only is between 5 and 7 inclusive. That means 5 and 7 should be included. So let me erase this. So now, so that means x between 5 and 7 inclusive. So it's going to be x greater than or equal 5 and less than or equal 7. And again, I'm going to looking for a probability of 5 or 6 or 7. And again, guys, or is addition. So P of 5 plus P of 6 plus P of 7. I'm going to, again, calculate each probability separately and add them up. So again, guys, P of 5 is going to be number of ways that I can obtain 5 successes out of 20 distinct objects times probability of success, that's 0.41 to the power of number of success, that is a 5, and then probability of failure, 1 minus 0.41 to the power of number of failure, that is going to be 20 minus 5, that is 15. And then I'm going to do the same thing for P of 6 and P of 7. And again, we add all these up. So rounded to the 4 decimal places, add these up, and the probability is going to be 0.33821. And again, guys, in 100 trials, if I multiply this by 100, we move it 2 places to the right. So since 8 is greater than 5, so it rounded to the 34. So we would expect about 34 trials to result in 5 to 7 households that are wireless only. Okay, guys, this is for that example. So now let's see what's next. So I'm not going to go over this one. So using technology, I'm going to do it later on, hopefully when we get back online. When we get back to the class, and then I'm going to show you how we use the technology for that. So not right now. So, okay, here we go. Okay, guys, now we know on Friday, I show you guys how you construct the binomial probability distribution. And then today, and actually Friday and today, I show you guys how we compute the probability distribution function. So now I'm going to tell you how we find the mean or expected value. So again, guys, remember that the other name of the mean for a discrete random variable is expected value, so mean or expected value, and a standard deviation of a binomial random variable. So a binomial experiment with n independent trials. So again, guys, it must be independent trials, n independent trials, and probability of success P has a mean and a standard deviation given by the formula. So the mean of x is equal to n. What is the n, guys? N independent trials times P is the probability of success. So that's the mean. And then the next one, a standard deviation, sigma x is equal to, so the standard deviation is going to be a square root of n times P times 1 minus P. And again, guys, a square root of n is n independent trials times P, probability of success, times 1 minus P is going to be the probability of failure. So now let's do some problem. Okay, guys, so let's do this problem together. According to the CTIA, 41% of all US households are wireless only households in a simple random sample of 300 households. So again, guys, now N is 300. So N is 300. Determine the mean and standard deviation number of wireless only households. So again, guys, N is 300 and probability of success is 0.41. So again, guys, if I want to find the mean or expected value, as I told, the previous slide was N times P, so N is 300 independent trials times probability of success, that is 0.41. So 300 times 0.41, it gives you 123. And again, guys, if I want to interpret this for the mean, I'm going to say we expect that in a random sample of 300 households, 123 will be wireless only. And then if I ask you find the standard deviation, again, the formula for finding the standard deviation of a binomial random variable is the square root of N times P times 1 minus P. Again, N and independent trials. P is probability of success. 1 minus P is probability of failure. So is equal to a square root of N is 300. Probability of success is 0.41. Probability of failure is 1 minus 0.41. I multiply all together. 300 times 0.41 times 1 minus 0.41 is 72.57. And then at the end, I take a square root of it. So it's going to be 8.5. So the standard deviation is 8.5. So, okay, guys, now this is very important. Okay, so again, guys, let me tell you, this is only an example, but I'm going to, from this example, I'm going to make a general conclusion. But please, guys, stay with me, okay? So, let's see, graphing binomial probability distribution. So, part A, problem. Part A, graph the binomial probability distribution with n equal 10. So again, guys, n is equal to 10 and probability of success is 0.2. Okay, guys, if I see, if I want to show the graph of this, so you see that this is actually a skewed right because tail to the right is longer. So this is a skewed right, correct? So part A, when I graph this using technology, again, guys, I give these data. This is possible value for X, 0, 1 through all the way to 10. And this is the corresponding probabilities of each value for X. So if I punch this in the technology, so it gives me this graph. So again, guys, make sure n is 10 and probability of success is 0.2, and you see that this is a skewed right. Okay, so keep that in mind. Now let's see what happened in part B. Graph the binomial probability distribution with n equal 10 and probability of success is 0.5. Again, guys, just be careful. I don't change the value of n. It still is 10, but probability of success, I increase it. So from 0.2, now we go to the 0.5. So we're exactly in the middle, okay? So now let's see what happened when I said probability of success is 0.5. Uh-oh. N still is 10, but probability of success is 0.5. Now the shape of the distribution is bell-shaped. It's bell-shaped. So now let's look at part C, and look, part C now it says N is equal 10, but probability of success now again increase from 0.5 to 0.8, almost close to 1, okay? So now see what happened. Again, just concern that N still is 10. I don't change the N. N still is 10, but I just increase the probability of success from 0.5 to 0.8. Now look at the shape of the distribution. Uh-oh. The graph of the distribution now is skewed left. So left to the tail is longer, so this is a skewed left. Okay, now okay guys, let's see. Okay, here we go. Okay guys, now let me conclude something from here. Okay, based on the result of the example 7, we conclude that the binomial probability distribution is skewed right if the probability of success is less than 0.5. So if I don't change N is equal to 10, and probability of success is less than 0.5, the binomial probability distribution is skewed right. And then symmetric and approximately bell-shaped if P is exactly or roughly equal to 0.5. And then a skewed left if P is greater than 0.5. So okay guys, now see what happened. If now I'm going to say, okay, you know what? Now I want to have a fixed probability of success. So I'm going to have a fixed probability of success as 0.2. So the probability of success is 0.2, but I'm going to increase number of independent trials, okay, and see what happened, okay? So please guys, look. Okay guys, look at here. If N is 10, so I'm looking for A, graph A. So in the figure 12, graph A. So if N is equal to 10 and probability of success is 0.2, and remember, we put this as a fixed probability. So again, guys, it's the same as the example 7. The shape is going to be skewed right. Okay, guys. Now look at part B. Again, guys, the probability of success now is fixed, 0.2, but I'm going to increase number of independent trials from 10 to 30. Uh-oh. Now it still is kind of skewed right, but it gets more, looks like a bell shape. Uh-oh, now part C, you see that still we have a fixed probability of success, 0.2. Now we increase the number of independent trials from 30 to 70. Now this is approximately bell-shaped. Okay, guys, now see what is my conclusion here. Okay, guys, make sure, make a big X mark next to this. For a fixed P, So again, guys, so P is what? Probability of success. So for a fixed probability of success, as the number of trials n in a binomial experiment increases, the probability distribution of a random variable x becomes bell-shaped. So as a rule of thumb, if n times p times 1 minus p is greater than or equal to 10, again, guys, n is n independent trials times p is the probability of success times 1 minus p is the probability of failure, greater than or equal to 10, the probability distribution will be approximately bell-shaped. So if I want to check for the binomial experiment, for the probability distribution of a random variable, if it's bell-shaped or not, I can check with this formula, n times p times 1 minus p. If it's greater than or equal to 10, the probability distribution will be approximately bell-shaped. So if that holds, that means if n times p times 1 minus p is greater than or equal to 10, then, so this is approximately bell-shaped. If it's approximately bell-shaped, then I can use the empirical rule. So this result allows us to use the empirical rule to identify unusual observation in a binomial experiment. Okay, how? Okay, guys, based on the empirical rule, we know that the 95% of all observation lie within 2 standard deviations. So the 95% of all observation lie within 2 standard deviation. That means between mu minus 2 standard deviation and mu plus 2 standard deviation. Again, guys, you guys can go back to the chapter 3 for the empirical rule, and you see that the 95% of all observation lie between 2 standard deviation, mu minus 2 standard deviation and mu plus 2 standard deviation. So any observation that lies outside this interval, that means above mu plus 2 standard deviation and or below mu minus 2 standard deviation, may be considered unusual because the observation occurs less than 5% of the time. So let's make an example. Okay. According to the CTIA, 41% of all US households are wireless only. In a simple random sample of 300 households, 143 were wireless only. Is this result unusual? Okay, first of all, I want to see if this is approximately bell-shaped. And again, guys, I'm going to use formula n times p times 1 minus p. Again, n is n independent trials times probability of success times probability of failure. So it's going to be 300 times probability of success, 0.41 times probability of failure, 1 minus 0.41. So it's going to be 72.57, and that's greater than or equal to 10. So yes, this is approximately bell-shaped. So that means 95% of all observation lie between mu minus 2 standard deviation and mu plus 2 standard deviation. So now, based on the previous example, we know that the mean for that situation, as previous example, the mean was 123 and the standard deviation is 8.5. So the mean was 123 and this standard deviation was 8.5 from previous example that I showed to you guys. So now I want to see where is the location for between where is the location for mu minus 2 standard deviation and mu plus 2 standard deviation. So mean was 123 minus 2 times a standard deviation 8.5. So 123 minus 17 is 106. And then mu plus 2 standard deviation equal to 123 plus 2 times 8.5. So it's going to be 123 plus 17 is 140. And again, guys, I'm looking for 140, 143. So, and then look, 143 is greater than 140. So again, guys, I remember, if I want to see if this is something unusual, either is less than mu minus 2 standard deviation or greater than mu plus 2 standard deviation. And then again here, 143 that is mentioned in the problem is greater than 140. So that means it's greater than mu plus 2 standard deviation. Since any value less than 106 or greater than 140 is unusual, 143 is an unusual result. We should try to identify the reason for its value. Perhaps the percentage of households that are wireless only has increased. So again, guys, I'm just concerned about if this is unusual. So if this is unusual, because 143 is greater than 140, so it's greater than mu plus 2 standard deviation. So that's it. This is for section 6.2. So I'm going to done with the 6.2. I'm going to now I go and start teaching 7.1 and then 7.2 and see where we go. So again, guys, thank you so much for your patience. I hope you find this useful and helpful. And I post this in the Canvas and I let you guys know. Thank you and have a wonderful day.